Okay, so we have done till the part where we know we have a line y equals to mx plus c, we have a scatter plot, and these are some points around it. Okay, so what basically we are trying to achieve here is with this line is that if someone asks me that I have got a CGPA of 9.7, what will be the expected what placement what is the amount of placement I could expect from this college. Okay, so I will what I will do as a data scientist is I will go to my linear regression line, will see where does 9.7 lies, and on the dependent axis I will find out this value and tell this student that this this is the salary you might expect from this year's placement. Okay, so we will see how do we plot this line, what is the intuition behind it, what is the geometric intuition behind it. Okay, so let's start. Uh, this is CGPA and this is salary or say LPA. Okay, this is 4, 5, 6, 7, 8, 9. Okay, and on this axis we have, let's say, 4, 8 and 12 LPA. Okay, suppose we have a point this this this. Okay, and we draw this line based on some values of m and y. We will in future in some time we will see how these values are calculated. Okay, so what I want to explain here is, what I want to explain you here is that you will see that when we are plotting this line, it is not showing the reality, or like this student has got a CGPA of 5 and has got a package of around 9 LPA, let's say. Okay, but if I ask my regression line that if I have got a CGPA of 5, what is the salary I can expect? It is telling me that you could expect a salary between 4 and 8, let's say 6 LPA. Okay, so a person is getting 9, but my regression model is telling me that I will get a package of 6 LPA. That's strange, right? But there could be a student who has got a package, have got the same CGPA 5, but he might be placed for a salary even less than 4 LPA, like 3 LPA. Okay, so there could be thousands of points. There could be thousands of points on this XY plane, and I want to plot a line which represents this data the best. What I mean by representing the data best is that it minimizes these errors, which are the error I am getting, which what the error is defined here as uh, how much I am deviating from the reality. Okay, so this student has got a package of 9 LPA, but my model is telling he should get a package of 6 LPA. Similarly, this guy has same got the 5 CGPA, but my model is telling he must have got 6 LPA. So this is the deviation from the reality, and these are the errors which I am getting. Okay, so I want a line that best fits this scatter plot, best fits this data frame, and reduces these errors as much as possible. Okay, so let's see, we have data of 4 students. Okay, uh, I'm sorry for the pause. Yeah. we were here that let me check it's working fine or not. Okay, so we have a data of, let's say, four students. These are the students, and this is our regression line. Okay, so what we want to minimize is these distances. This is the error. Like this student has got this package, but my model is predicting this point. Similarly, uh, at this CGPA, my model is predicting a very high CGPA for him, a very high package for him, but in reality, he has got this package. Okay, so this is my error 2. This is my error 1. Similarly, these terms are my errors. Okay, so what is this? What is my total error? E1 plus E2 plus E3 plus E4. Not total error, but these terms represents the errors I am getting in my model. And as a data scientist or as a statistician, I want to reduce these error terms. I want that my model stays or predicts a very close data to the reality. My model predicts something close to reality. I want that. And that could be achieved how? Okay. So what basically here happening is we have three columns, right? This is the CGPA. This is the actual placement, and there is something, the prediction, whichever model is giving to us. Suppose CGPA was 8, LPA was 12, but my prediction was something like 7 LPA. Okay, so I represent this by Y, and I represent this prediction by YI hat. Okay, so this is Y1 and this is Y1 hat, and my error is 12 minus 7 equals 5 LPA. Okay, this is my error for this term, and in general I can represent my error or the error of this point as y1 minus y1 hat. Am I right? So the sum of my errors would be, so I don't have a single data point, right? I have multiple data points, and there could be some the actual package and the prediction for it. So so this could be error 1 plus error 2 plus error 3. Okay, so this will be my total error of my graph or my model. So I can represent it as summation yi minus yi hat. This is my error function, and I want to minimize this error function. I want my model to predict something close to reality. So I want these distances to reduce, something like if these are the points, I want this line to be close to them. So these deviations or these differences are minimized, and this would be my best regression line. Correct. Suppose my points are here and I made a regression line this. So this distance would be so bad, and my model would be predicting something very different from what is there in reality. So I want to plot a line like this which minimizes these distances. Okay, so that's the whole story of regression line, and this is our error function, and we want to minimize this function. which we want to minimize this error, and hence we want to minimize this function. Okay, so we can write it as error is a function of y and yi. Okay, and if we proceed, error equals to summation yi minus yi hat. Okay, so let me explain what is the summation. So I have these points. Okay, these are my row 1, row 2, row 3. So, and this is CGPA. This is actual placement LPA, and this is predicted LPA. Okay, so what does this represent? And this implies y1 minus y1 hat plus y2 minus y2 hat plus y3 minus y3 hat plus yn minus yn hat. So basically, this amount minus this plus this minus this plus this minus this. This will give the total error of my model, and I want to minimize that error. Correct. So the error function is e equals to yi summation yi minus yi hat. And now, what do you think this yi could be? How this prediction is coming in our model? How this value is calculated? So if you can think about this, please pause the video and think or write it on a sheet of paper that how this value is calculated. I give you a hint, we have studied is this in this lecture only, and you can easily tell this prediction is coming by y equals to mx plus c equation. So if we are given this m and we are given this c, suppose our m is 2 and c is 1. Okay, so and if I put in the value 8 in this function, okay, c could be any number, it could be positive, it could be negative. So this is 16 minus, let's say, 5. So the value would be 11 LPA. Okay, so this would be 11 LPA. If I say a student has got 9 CGPA, okay, so what could be the prediction, or what will be his salary? What will be his predicted salary? So I will put this value in my function. So his LPA, that is the predicted, equals to 9 into 2 minus 5. This is 14 LPA. This is 14 LPA. So I think we got it, where this value is coming from, or what is yi hat. Yi hat is nothing but it is mx plus c. I think I am clear at this point. So I can write it as summation yi minus mx minus c. And this is my error function, which I will minimize. And what is in my hand which I could minimize? What are the terms? These two are the terms which are in my hand. This is given to me in the data. Okay, sorry, this is given to me in the data, and this is also actually given to me in the data, or a new value could be given to me of x, and I will be predicting my yi hat through this. Okay, so and if I want to minimize this error function, what do we do? I will partially I will do its partial derivative first with respect to m and put it equal to 0, and second I will partially derivate this function with respect to my c. It is not a constant, it is the intercept, and put it equal to c. So in the next part we will see the derivative of this function, and how could we find the values of m and c so that this total error function is minimized and we get a regression line which is close to reality. The distances are small. Okay, so thank you, and we will see continue from here in the next part.